I usually don't make videos if there's lots of videos already on the same topic, but I like to just have a single video that I can send my students to, which covers what I think of as the three main approaches to solving equations with modulus signs. My personal favourite method is the sketch method. For various reasons. I think it's just clearer. I can see what's going on. I typically am quite I tend to picture things when I solve them. I'm always a little bit nervous of trusting algebra. Also, this is more applicable in more general situations. I think it's a more useful skill. Whereas I think you at some point you may need to draw a graph like this, but you may never have to use any of the other techniques, if that makes sense. So I'm like, well, let's not learn skills which I can kind of get away with not learning. Let's just keep rinsing and repeating other things. Anyway, so this left-hand side here, let's have a look. That would be when x minus 3 has the modulus sign working, so that would be the minus arm. And the 2x also has the minus sign working because it's on the minus, it's where the modulus has had to activate. And on the right hand side, so let's just separate those so we're nice and clear. This is still where it's minus, but the 2x, the modulus signs aren't actually doing anything, they're not changing the sign. So I'm now going to make this minus x plus 3 equals minus 2x. There's so many minus signs flying around, I'm very nervous, so I'm going to be quite careful here. So I'm going to add 2x to both sides. So then that would make x equals minus 3, because I've just shifted the 3 at the same time, so I was going a bit fast with those minus signs flying around. This would be minus x plus 3 equals 2x. So I could plus x to both sides. So I'll make 3 equals 3x. So x equals 1. There we go. Second approach is the plus or minus approach, what I call the plus or minus approach. That could be plus, that could be plus, that could be plus, that could be minus, that could be minus, that could be plus, that could be minus, that could be minus. They effectively mean the same thing, and these two effectively mean the same thing. So we only need to consider the case where they're both plus. So, because let's just pick that one. Or where one is plus and the other one is minus, and that covers all possibilities. So then I'll just stick a line down so I don't get too confused. I'm going to plus x to both sides. No, I'm not. I'm going to minus x to both sides, which means I get minus 3 equals x, or x equals minus 3, which is satisfyingly similar to the previous one. And then so many minus signs flying around. Let's do plus 2x. Having to be very careful here. So that would make 3x, and then I'm just going to sling the 3 over the other side. Equals 3, so x equals 1. So there you go. Same two answers. There's another way of solving it as well. This is kind of my least favourite method. It just bugs me. I like to do things which feel really kind of physical to me, that I can kind of my intuition can kind of feel like it knows what's going on, which is why I like the graph. Anyway, you can just square both sides. It's a pretty standard approach. So that'd be x minus 3, x minus 3. Do you know what? Why am I doing this? Because it's quite high level maths. I don't need to spell everything out. So that's x squared minus 6x plus 9 equals 4x squared, which means we have, let's just sling everything over so it's on the same side, plus 6x minus 9 equals 0. We just need to sling some brackets in there. 3 is a prime number, so assuming it factorizes, that's going to be that. It's got to be a minus, it must be a minus and a plus. We need the plus to be bigger because the middle needs to be big. Boom, there we go. So we got the same answer again. So x equals minus 1 or x equals minus 3. 3 different approaches. My personal favourite is the graph approach. hopefully that was helpful for you.